how did you find it out? You looked up at your notes, and that's what I did over here myself. That's my cheat sheet I had from college. Anyway, so you just look it up, and I'm going to give you these formulas for the test. So sine, cosine, and e to the x. And then we know how to actually get them. So based on that formula, I'm going to just use a couple of approximations, just a couple of terms. So particularly I'm going to say sine of theta can be approximated by, what's the first term in this series?
1.
Hmm?
1.
0.
When n is equal to 0.
0.
N is equal to 0. Just think about it, talk to your neighbor. What's the first term in that series? Theta, exactly. So if I put an n equals to 0 over here, I'm getting theta to the power 1. Okay, so that saves theta. And then I've got another bunch of terms over there. What's the next one? It's got a negative, and then I've got theta to the power 3. So remember, that was the one with the odd terms. And so then it keeps going, and then it keeps alternating plus or minus, plus or minus, plus or minus. Okay, perfect. So we can say that theta is approximately theta. Sorry, sine of theta is approximately equal to theta. And what about the remainder? So what I want you guys to work on is get an estimate for the remainder. I want to know how big an error I'm making if I am just stopping over here. And that was just what we have. The Lagrange error bound is the kind of tool that we're going to be using. Okay, so work on this, and then all of the problems that follow that are similar, just
Looking at errors for what?
looking for errors and bounding those errors.
To what degree?
To what degree? For any
Make sure that each team has a captain, so the captain is going to be responsible for,
any plus what?
coming up with
Today.
a uniform solution.
You're the captain. For what degree? Or is that just stopping at? Yeah.
So get a captain.
N equals 0.
So this is 1 point. To what degree?
What's the degree? It's only one term. Exactly. So what's the degree of that? Look at the polynomial. Look at the polynomial. 1. Okay, so that's the good one. Then we'll let you
degree.
discussion.
Specific to a certain number?
Yeah, I thought it was just
Is that like degree 4 or like degree 3?
I didn't hear.
Or sine of theta.
But would it be 1 to negative 1 because it's always like this?
Oh, that's the first. Theta is 0 degree. That's first
Theta, what's the
degree.
degree of theta?
No. Theta, that's like, when you plug in 0 for x, so that's 0 degree.
One.
But is that the first degree polynomial or is it 0 degree?
It's the first degree polynomial. Because it has degree 1. So you have to look at not the n, because the n is like a j, whatever, it doesn't really matter what number it has. The problem is that you want to look at the degree of the polynomial. So if it's a theta, that's a degree 4, theta squared, degree 2, and so forth. So that's the idea. So it doesn't matter that it's the first term. Why?
Because there is no theta squared.
There's no theta squared, exactly. So it would be like a 0 times theta squared. That is a very good point. So make sure that everybody has a degree. So get the error, and then move on to the next question.
Oh, why are we?
What does she tell them? Right?
No,
I thought she said
And then like the bound theta, for like all of theta would be 0 to 360 or something. Or like 360.
Yeah, what is 2.0 and
'Cause I mean, they're the same thing. Yeah.
That happened at
So our ends 2.
someone
Right,
like
because n of 1, when n equals 1, there's no value.
Right.
Just do degree 2. So that's pi minus. I'm not pi,
Okay, we're
theta.
starting at n equals 1.
So
We're doing like n equals.
n equals 0.
Two.
2. For n equals 0 equals 1, it's the same value.
Because the n equals 0 and equals 1.
Okay. So
N here has different
okay. But and I'm guessing if this n equals 1, the one term equals 0. So
well, there's no problem here. When we have a function here, add those 2 and plus 1.
we have to find how big.
So if n equals 0, we pick up 1. And then if n equals 1,
And theirs is a hill country.
Now we have to do math. We have to do math. Only. How am I gonna do it? Right, it's just,
The equation he used was
you just relate sine to 0, which we already know is 0.
yeah. Here, f of x minus the Taylor series.
0 minus. Do we just make up a point to pick? Because it says near 0, so do we go like 0.001? Because we would need an actual point. Yeah.
Is that what we're used to?
Yeah. And then it has to be less than or equal to the m over n plus 1 factorial.
Yeah.
What's n? Equal to?
It's the carrying
It's
class.
it's some yeah, it's like a given constant. It's not given, excuse me. It's some constant that
It's like plus 1 of like if like you have a Taylor series and you go to a certain point, right? So plus 1 of that, right?
something. Let's
Because we're doing sine of theta, right? For f of x
Yeah.
minus that whole thing.
It's you have to look at the domain.
Okay.
What order are we doing this?
She didn't give us one.
How far?
Okay, I'm good with that.
Yeah.
I just went to 7. Oh, I just yeah. Alright. So this is less than or equal to n over n plus 1.
that's what we've done. Yeah.
Okay, the error, this right here, this Rn is basically the error, like Rn is the error of the nth degree of polynomial. So we're trying to find out the Rn for our polynomial, okay? So n is a degree, okay, first of all, n is a degree of a polynomial. What degree is a polynomial we have?
That's 1 and so there's 2 factorial.
What are we saying? We're saying sine? Instead of sine? What are we replacing sine with?
And then
What degree polynomial? Huh? I don't know what we're doing. What is? Or also look at what is that function of sine theta, right? We're only
that's
using
third degree.
we're only using the first term, so we're only using the degree.
Yeah. Okay, so
That's it. So our degree is 1. So n equals 1 and then
yeah, it's just 2.
you have to use it. So you have to calculate what R1 is.
It would be negative 3.
Right? So you have to find out what m is. Because m is the bound of the n plus 1 derivative. So how are you going to find that? So 0, 1, 2, 3. Exactly. Yeah. And now you need to find out how big the second derivative can be. That'll be your answer. You see why, right? I mean, just differentiate twice, you get the big something big one, right? Okay. And now, okay, that's it. I mean, now you have your m. What's this? This is factorial, and this is just x minus 0, right? And that's how big this guy can be at 1. That's how big it can be.
So for ours, it's like sine of theta minus 1. So like,
So really, it's R and 1, but then
But the important thing is that they have different meanings, like activator and activator.
Right? So what's the biggest? For any
See, you said that the chef was so cool. She gives you 2 grades. That makes it like. And it's right next to where I'm going to be next. We've already started this semester. I'm going to read it right.
a little in trouble. In this case, actually, it's okay that sine is bounded between -1 and 1, right? So it doesn't really matter. And actually, your remainder will depend on which x you're looking at. You see? Right. So it's positive.
This is not too long, guys, okay? We'll try to cover all
Does
of
it
the
make sense what I'm
exercises
saying?
that we have.
well, it wouldn't matter because they're taking absolute value.
Yeah, you're right. Yeah. But so yeah, okay, that's right, that's right. And what's this? What do you have? Why do you have cubed? Oh, we're using this formula here, right?
Yeah, that was, we were using second n is 1.
And it's 1. Okay, exactly. Okay, so anyways, that's why there is an interval here, because in this case it's nice. Like sine is bound between -1 and 1. So, okay, it's right here, right? So, which derivative do you need to do?
they did earlier.
What's your n? Okay, so n is the degree of your Taylor polynomial. What's the degree of a Taylor polynomial?
Probably you should get as long as you know, we can solve it.
I think some.
So that's what n is. So which derivative do you have to compute according to? Yeah, second derivative. Now, what's m then, according to this? Yeah, why is it 1? Yeah, 1 works. Why is it 1? What this is saying is m is the biggest your second derivative can be. The max of your second derivative. Okay, what's your second derivative? Of sine? So, negative sign. Okay, but you're taking absolute value, okay, so the negative doesn't matter. So now,
M is what's the biggest that can be? Sine. So 1 works, right? So here you can take M equals to 1.
Okay.
Make sense? Zero. No. It's what up? By 0 do you mean R
N 0.
n equals 0?
So it's R 0 theta, but then it's gonna be 0 plus 1. So it's
No. Okay. But n is a degree of equal polynomial.
Yeah.
But she cut it off at theta. So it's
So, no. So, we're using, instead of theta, we're approximating it with just theta. What degree polynomial is this? What we put here? What degree is it? 1. Right? Exactly. Yes. So, n equals 1. See that?
How is that? Okay, so that's how if you're finding okay. That is the Taylor polynomial degree 1 is theta minus theta. Like,
Okay.
so that's when we're saying that the degree 1 is just so that's
In this case for sine, the degree 1 to the polynomial is just 2.
but that's your intercept. That's
Okay.
is it going to be different in a different function besides that? 'Cause
Yeah, no, the way you should judge what degree polynomial you're using is by the highest degree of your polynomial. Because in this case, for sine, notice how the polynomial skips between even and odd powers. It only has odd powers.
yeah.
Yeah? So, this polynomial only has odd powers. So, what was the point I was saying?
I just thought what we did was it's even though.
Yeah, so see, in this case,
T0
so for example, if we would just stopped here, that would have been a degree 1, degree 2, degree 3. Yeah, but that's not what should tell you the degree. What should tell you the degree is the highest power of your. Alright. Okay, which is tricky in this case because this Taylor series skips all the even terms, you see? So there is a term before the theta, it's just 0. I don't know what that makes sense. Yeah, it's just 0. And actually, there is also going to be a degree 2 term, but it's also going to be 0.
If we had a constant before that, it would be.
So like if it's 0 equal, like, is it ever gonna if you lift it at 0, like you will
Exactly.
Oh,
Yeah. So actually, so here, okay. So for sine of theta, that's a degree 1 to the polynomial. The degree 2, okay. According to the Taylor expansion, is there any degree 2? It's going to be 0, right? It's going to skip all the way to degree 3. You see?
I think there's
How to get the math?
the max.
Oh, the max.
Okay, I know it's like F double so
It's just the biggest, so basically M
is the biggest. That's
the biggest of second derivative.
But I don't know what the bounds are there on and negative.
Okay, yeah. Sometimes you won't need bounds. In this case, actually, we don't need bounds because what is the second derivative of sine? Okay, take absolute value, so forget about the negative. Okay, so what's the biggest sine can be in any interval, anywhere? 1, right? So in this case, you don't really need intervals. Yeah, but you're right though. In some cases, we're looking at a function that kind of, explodes. Then you will need some bounds to keep it from doing that. But in this case, sine and cosine are bounded between -1 and -2. So that's your m. If your m, you can use 1.
But what's M?
But you're right, since we don't have an interval we're looking at, your error at a point x is going to depend on how big x is. So what I'm saying is, this Rn of x will have an x here still.
Yeah, so how do I get...
There you go, yes.
Okay, I don't know what to do.
Yes, that's it. That's
It's at
the
here.
yeah. The error of the degree 1 to the polynomial at a point x is at most this. Yes, that one. If you had it in an interval you're interested in, then you could even get like a.
Got it. No, I was following along and I got it too. Okay, so like, okay, we're starting at degree 1, and then to get the max, would you get a second derivative? Right? Okay, and your second derivative is negative sine theta. You do the absolute value, so it's sine theta. And the max, any sine theta can be 10. So that's your max, and then you just put in. And since it's set around
Hey, that's technically wrong because that's theta.
I get that.
I think I get that.
So then M is 1
Yeah.
because the
Max
max
is
is right.
Excuse me, a bit louder. What
And we're
was
doing
that, Amber?
degree 2. Correct? A is at 0.
I was a little confused. I forgot that this is saying that that equals that, so I'm like looking at that part. Consider that.
Thank God it's not correct.
I thought our n was 1.
Oh. I thought our max was just 1 and N was still 2.
Oh,
there N one
we
or
do
two?
Sunday. 1.
N is 1.
But you do the F to the N plus 1.
You get to meet my...
Okay.
Oh, she didn't want to. No, I told her she can eat dinner with me on Sunday. At the... What was that face? What? What? Huh? That's really you. It's the imaginary unit. No, it's a unit. It's just imaginary. So it's a constant. It's a constant.
I see that on paper.
I remember the unit. That's imaginary. I thought it was literally.
So, does it make sense what's going on here? It's very important, the two ends don't mean the same thing, so let's just talk about J and then... Good. So now, here is always going to be the polynomial. So, move on to the next problem. What are we doing here? Number 5. No, move on to the next one. What's the... And you could also split up into subgroups if you want. So that if you like one of the problems better than the others, you focus on that first. Okay, any questions over here?
Detailed explanation for the cosine one is.
The derivative is negative sine.
Not the derivative. Oh, it's like the similar as this. It's like -1 to n, but it's like theta to the 2n over like 2n factorial or something like that. It's just going to be similar. No, it's like the same. It just has a cosine is this one. Negative 1 to the n over 2 n factorial x over 2. So it's all evens.
Yeah, it is all evens. But then the plus and ultimate just differently. The initial one's plus rather than the minus, like asset. And then the next one.
Make sure, guys, that
Oh, shit.
move on to the next problem.
That is a constant, right?
Does that make
That's wrong.
sense? Yeah, that's wrong.
You don't need to know
Yeah.
What is that one? A squared over.
They just said 1.
Okay.
I put the wrong thing in the beginning because f bat's 2n. Or is it 2n over 2n next one? No, that was right.
Why can't he come up here?
Yeah. We'll just.
So finding series of
from here, exactly. From here, you sum the whole
Yeah, if I don't have
And it's like a quick opportunity.
Are we winning? We were winning.
Did you try using the negotiation? Using the negotiation? Using the But I'm not sure what it would be. Oh, well, I worked out the but the thing is, I'm not sure if this is easier or this is
Make sure that everybody knows
You're not seeing any patterns?
What is the second degree Taylor polynomial for sin of theta? Second degree Taylor polynomial theta, excellent. So it's a theta. So what we're saying here is that sin of theta is equal to theta, but not quite. Okay, it's got a remainder. And then we've got an R2 of theta. And that's going to be near theta equals to 0. So what is it we're doing? We're trying to estimate, so how big is this? Well, we're looking for Lagrange. We're going to ask help. And he says well, look at the derivatives for the function. So what are the derivatives of sine? And they're just sine and cosine. So essentially, we're looking for a bound for the derivative, which is a positive bound. 1, exactly. So we're never going to have a sine or cosine function bigger than 1. So m is our bound for the derivatives, and so that's going to be equal to 1. And so we have our estimate right here, 1 divided by 3 factorial, and then we got theta to the power 3, and that's it. And now, if I'm like, for example, a little bit past 0, so for example, I can see how big the error is when theta is a specific number. So what if theta is actually equal to 0 point, anybody? 0.1, okay. And so we're going to have the remainder at 0.1, and that's going to be less than 0.1 cubed divided by 6. So that's how big the error is. And so another kind of thing that we can do is to say, well, if I want to get a bound less than something, how big, what's the biggest theta that I could get? Okay, anybody worked on any of the other problems? Yep.
How do you know that to go the second degree? Like if you didn't know it, how do you know?
Oh, the thing is that we can look at it from where we started. So the idea is that the Taylor polynomial, so we have sine of theta, which is theta minus theta cubed divided by 3 factorial plus theta 5 factorial minus blah, blah, blah. And the point is that we are stopping at theta. So that's the kind of approximation that we're getting. What we're saying is approximately equal to theta because we just decided to take that as an approximation. The problem tells us. Here's what we're doing. Instead of sine of theta, we're replacing it with theta. And so technically, we're stopping at degree. What's the degree of this? What's the degree of this polynomial? 1. Okay, we're stopping at degree 1. And the issue is that if I stopped over there and take just the power 2, then, well, I would get a theta to the power 2 over here. But I can actually do better and take the power 3, so I'm actually reducing the error because this is also the degree 1 polynomial. It's also the degree 2 polynomial because sine of theta skips all of the even powers, and so there's no difference between degree 1 and degree 2 Taylor polynomials. These are Taylor polynomials. So it's a problem that tells us essentially where to stop, or it just as, okay, because we just need to set up a level of happiness. When we do our experiments, we have some data and we have some errors, and we can say, well, I want to have as precise an error as possible, or as precise an estimate as possible. And so I could decide to go up a couple of powers in order to shrink the error. Okay, any other questions? Yep.
So can we just, if it's not specified, can we just pick
Yes,
or a
yes.
degree to
Yeah, we can pick, sometimes it says what to do. For example, let's look together at the problem of approximating pi using the Taylor polynomials. So how many Taylor polynomials can we do? Well, we've got our tangent of x, and we're looking for a Taylor approximation of our tangent. And then we're going to use that to estimate the numerical value of pi. Why would that be useful? I mean, how can that help us? Why our tangent? Oh, arc tangent is actually very bounded, yes. But what's the reason? Sorry? Tangent is not, so that wouldn't be maybe a good idea. But what's the relationship between arctangent and pi? Why are they? Why is it going to be a good idea to use arctangent?
Because that's the limit. Like that's the highest it goes, right?
What's as high as it goes?
It doesn't go above pi. As
over
So it doesn't go above what actually?
pi over
Pi over
2.
2.
Pi over 2. Pi over 2, yeah. But that would be like a limit at infinity. So we're not actually really getting pi or pi over 2. So that would be at infinity. Yeah.
Is like the range equal to pi?
Sorry?
The range?
The range is equal to pi. What else is equal to pi? Is there... well, what's arctangent? How do I define arctangent? So yeah, arctangent of x equals to, let's say, theta.
No, 1 over 10.
What does he mean? Have fun, everybody.
At that equal.
Yeah, so the angle, so the tangent to that angle theta is going to be equal to x. So that's the definition of arctangent. And is there any relationship, anything that plugged into arctangent is going to give us pi, or some sort of pi-related anything? Start your neighbor. And try to find a relationship between
Tangents,
arctangent.
the points are always like 2 or something, right? There's no pi in the tangent of anything.
Tangent of pi, it wouldn't even be, pi wouldn't be there.
The way she wrote it, tangent of theta is equal to pi.
I know when you're doing this, when you're doing a triangle, pi wouldn't even be there, right?
Yeah.
But isn't it like doing sine of what?
Like tangent of
Sine
theta
of
is
pi over sine of pi over 2 or something, or what is it?
If you did like inverse sine of pi.
Sine of like pi over 3. That like you change the angle. So like tangent of pi. It's like you don't make that the
Inverse tangent of x. This is x, basically. X is equal to theta, right? So when you rearrange it, you're doing tangent of x. No, tangent of theta is equal to x, right? So if your x equals pi, your tangent of your theta is going to equal pi. So it's going to be opposite over adjacent equal to pi. So
wait, x is equal to pi?
Opposite over adjacent, yeah. The numerical value of pi. What if she said x that is 0 and tangent?
I just don't know how chances do like all these weird stuff without
I'm good at these.
how to do them first, you know? Like chances teaches how to do this example. Because we waste time trying to do it.
Because remember, arctangent is between negative pi over 2 and pi over 2, right?
You want it to be within range.
So yeah, you want to have something involving pi. So you know there's no value of x you can plug in that'll give you pi, because it's not in the range, like you said. Also pi over 2 is also in the range. So maybe pi over 4.
So then this says arctangent of x equals 4. Tangent of pi over 4 is going to equal our x.
Yes. They're not. They don't convey like what he goes over.
Okay.
That's it.
Okay. You guys, I got it. This is 1.
No, I think it's
Guys, are we asking what from? What are we doing here?
Oh no, we're working on, or I'm working on. We don't know that derivative of
What's it
arctangent.
called?
Oh, but how are we gonna use? Oh, a derivative of arctangent we can ask for from. That's okay. 1 over 1 plus x squared.
Isn't that tangent?
That was the
1 over 1 plus x squared.
no, that's the arctangent.
Oh.
But why is that useful?
For
Why am I considered arctangent?
right?
Why? I mean, afterwards, I'm getting that you're talking about the Taylor expansion of arctangent, and that's awesome. But what am I going to do with that?
I don't know, I'm just looking for someone to try.
Yeah, that's good. Well, let's have a plan. So we're leaving the complications to Wolfram, okay, Bobby?
Okay, what should we use the unit circle?
We're trying to find some relationship between tangent, arctangent rather, and pi. Is there any value that we can plug in, for example, that's going to give us pi or a multiple of pi? Or a fraction of pi? Arctangent of 0, 0, so it's not going to give us pi.
If we use like a really huge number and that's what that might
Arctangent of...
then you take the limit times.
But that would be involving a limit, so that's a little bit tricky. Anytime you're talking about infinity, but is there anything kind of closer? Because we're gonna wrap it up on Tuesday. The thing is that when you have the limit at infinity, remember Taylor expansions are always local. So if I'm gonna use a Taylor expansion, then it's gonna be like local at 0. And then what happens is that at infinity, it might be just too far away. So that's the issue. But can we get any closer? Is there anything that gives us pi, pi over 2, pi over 4, pi over 6? Correct. But is there any value of r that you can put in the x? Is there any x that
You'll have to
say
bring two
arctangent that is equal to multiple of pi?
That's what they said at the meeting. They were
That's
like,
the issue.
yeah.
Because then we can do a Taylor expansion and see what happens.
If you need the information to figure out, then you have to.
Well,
I want to go.
Yeah, you don't get in
no,
trouble.
you don't have to worry.
It was really useful.
I hope not.
We like didn't do it in the meeting.
Is there a
Here? What? Yeah.
No, it's free for everybody.
You have office that way.
Okay.
Yeah, right now.
Okay, yeah. I have a class with one.